All right, guys, let's knock out this practice test 8 right here to get you ready for your test tomorrow. Last one before fall break. Let's do this. Number 1, 2, and 3 all have the same type of problem. The first one says f of g of -2. Remember what we're going to do? We're going to take -2. We're going backwards. Plug it into g first, which is right here. So if I plug it in there, I get -2 squared minus 2 times -2 minus 6. Now, if you're going to use your calculator to punch this in, you must use those parentheses. If you don't, it's going to mess you up. It's going to be 4 plus 8. Sorry, 4 plus 4 is 8 minus 6, that's 2. Now, that 2 right there, that's not the answer. Okay, the 2, now that you found, put the -2 into G and got 2, now you take the 2 and plug it into F, which is right here. So I'm going to say, okay, that's going to be 3 times 2 plus 1, which is going to be 7. That's the final deal right there. Okay, so that's all you do. Number 2, same type of deal. -3 is going into H first, which is right here. So if I plug -3, again, use your parentheses, -3 cubed, that's -27. And then you do the same thing. You're going to take -27, go backwards, plug it into H again. So I'm going to do a -27 cubed, which everybody knows is -19,683. That got huge because we really cubed it twice. And the last one, g of f of 5. So I'm going to put the 5 in function f, which is back here. All right, which would be 3 times 5 plus 1, which is going to give me 16. Then don't forget to do 16. Take the 16, plug it into g, which is going to be 16 squared minus 2 times 16 minus 6. You can punch all that in if you want to, and you're going to get 218. There you go. I'm going to practice those, make sure you got that. Number 4 says find f of g of x and the domain. Okay, now when it says f of g, I'm actually taking function g and plugging it into f. So I'm taking this whole thing right here and plugging it right there. Okay, so it's going to look like this. 5th root of x plus 2 to the 5th power, because it's x to the 5th. You just put it in where the x was, -2. Now we're going to work that out. If you raise a 5th root to a 5th power, they just cancel. So it gives you x plus 2 in there, -2. That's just x. Okay, that works, not that difficult. Okay, but it says find the domain. The way you find the domain for these is you take the second letter, the G, you look at the domain for that. Now, because that's an odd root, it's all real numbers. If it was a 4th root, it'd have to be positive in there, but because it's an odd root, it can be positive or negative, doesn't matter, so that's all real. So you compare that with your final answer, which is also x, which is just all reals also. So because we had all reals here and all reals at the end, the domain for the whole thing is all reals. All right, number 5. 5, guys, you got no strategy for 5. It says find f of x and g of x, so that h of x is f of g of x. So you got to come up with 2 functions, and there's probably 3 or 4 different answers here you could come up with. And the only rule is one of them cannot just be f of x equals x or g of x equals x. So what I'm going to do is, just looking at this for a second, I'm going to say the first one, f of x is x cubed. And I'm going to let g of x be 2 minus 3x. And think about this. If I were to work this out, if I were to work out f of g, meaning I'm going to plug g into f. If I took this and plugged it in there, I would get this, that's what you're trying to do. You're trying to break this one up into 2 different functions so that if you did f of g, you would get back where you started. Okay, 6 and 7. Determine visually whether the graph is symmetric with respect to the x, the y, and the origin. The first one, hopefully you can look at that and know, hey, that's symmetric with the y-axis, because if you fold this side over the y, it would match up perfectly with that side. 7's got a lot of stuff going on. First of all, it is symmetric to the x-axis. You could fold it over. Think about this, drawing that line right there, goes right through the middle, it's perfect. It's also symmetric to the y-axis, because I could do the same thing. If I do this line right down to the y-axis, it cuts it right smack in half. And if it's x-axis and y-axis, it's also origin. And also don't forget, origin symmetry means if you were to turn it upside down, let me do this real quick. If you turn it upside down, like that, it looks exactly the same as if it's right side up. That's origin symmetry. Also, remember we talked about this week, if you write x-axis and y-axis, I don't know what just happened there. If you write x-axis and y-axis, golly, x-axis and y-axis, origin is automatically one of them. All right. Tell algebraically whether it's symmetric to the x-axis, y-axis, and origin. Okay, so this is a 3-step problem. To figure out if it's symmetric to the x-axis, we're going to plug in a negative y. Okay, so I'm going to plug in a negative y. And if I do that, this is what I get. I get 3x plus 2y equals 3. Ask yourself, is that the same thing we started with? Nope. So it's no x-axis. To check for the y-axis symmetry, plug in a negative x. and see if you get the same thing that you started with. Now it would be a negative 3x minus 2y, which is not the same thing. And then origin, you plug in both. You plug in a negative x and a negative y. And let's see what happens here. That would give me a negative 3x, a positive 2y, I think. Yeah, positive 2y equals 3. Now you got to ask yourself, is that the same thing? No. And one more thing you got to ask yourself, what we haven't been asking, really only have to do this on the origin symmetry. Is it the exact opposite of what we started with? And the answer is no. The 3x and the 2y are, but the 3 didn't change. The 3 messed us up. To be honest, if the 3 would have been a 0, we'd have been in good shape right there. Okay, number 9, the same thing. Okay, so to check for y-axis is backwards what you think. To check for y-axis, you plug in a negative x. And this time I have a lot of good stuff going on. One, I have a square, which changes that negative back to what it was. Also, the 0 is going to be nice. So that's the same thing we started with. So it does have x-axis. Okay, so one answer is x-axis. You got to keep trying though. Sorry, that should have been y-axis. We plugged the negative x. Negative x for y-axis. To check for x-axis, you plug in a negative y for where the y is. So I'm plugging in a negative y. If you work that out, you're going to get 6x squared. Again, the square takes care of the negative, makes it positive. And that's the same thing we started with also. So it also has x-axis. Now, we just learned a second ago, if it's got y-axis and x-axis symmetry, the origin symmetry automatically works. I'll show you real quick anyway. If I plug in a negative x, if I plug in a negative y, the squares change it back to positive, which makes it positive 6x squared, positive 5y squared, equals 0, so it does have origin. That problem has all 3, which is crazy. All right, number 10. Does the graph of number 1 represent an even or odd? I don't think it's supposed to say number 1. I think it's supposed to say number 6. I'd have to go back and look at 6. Matter of fact, I'm going to pause this video, go back and look. So hang on, I'll be right back. Matter of fact, you won't even know I'm gone. All right, number 6 is the graph that looked like this. It kind of did this. You can look it on your paper, obviously, but that's terrible. It's kind of like that. All right, it's kind of a U shape, what kind of goes out at the ends. That is definitely symmetric to the y-axis. Remember, if it's symmetric to the y-axis, that means it's even. If it's symmetric to the origin, it's odd. Okay, even is y, or odd is origin. I kind of remember like the O's go together. Odd function, origin, symmetry, even y. Even y. All right, number 11, determine algebraically. Okay, same thing. I got to try for even and I got to try for odd. Actually, on this one, if you listen today pretty well, notice the exponents are odd. Anytime the exponents are odd, it doesn't mean it's odd, but what it does mean is that it's not even. So I'm really going to test for the even stuff here. I'm just going to test for odd. And remember what odd means. Odd means origin. We just did origin up there, which means you got to plug in a negative x and a negative y and see what happens. So I'm going to take a negative y right there. I'm going to put in a negative x for the x's, like this, and then just work it out. The y is negative. This negative, because it has a cube, the negative x has a cube, it's going to stay negative. A negative times a negative is a positive. That makes it 3x cubed, and it's going to make that a negative 2x there. So I'm looking at this, and I'm comparing it to what we started with. And first thing I notice is it's not exactly the same. But the second thing I've got to look at is it exactly the opposite. So look at the y first. The y went from positive to negative. That's good. The x cubed went from negative to positive, and the 2x went from positive to negative. So it's the exact opposite, which means it would be odd. Remember, if it's exactly the same or exactly the opposite, then it's good. All right, number 12, be careful on this one. This is not hard, but please be careful. Subtract 1 from all 3 sides. I hope you know I'm subtracting 1 because that's a positive 1. That leaves me a negative 2x in the middle, a 2 out here. Oops, that's not a... and a negative 4 out there. Now I'm going to divide by negative 2. Don't forget what that means. All right, if you divide by negative 2, your signs flip. That becomes negative 1. This becomes 2. So x is between negative 1 and 2. So you'd write your answer like this. Bracket with a negative 1, a 2 with the parentheses. Because this one has an equal sign, that one doesn't. There you go. 13, you've had this about 2 or 3 weeks in a row now. You should be getting good at doing the slope-intercept forms of parallel perpendicular. Okay, so first of all, slope is 2. Right there, slope is 2. If I'm going to do parallel, I'm going to use that slope, and there's my point. Remember, put the opposite of the point. Put y minus 6, put 2 times x plus 1. Boom. It takes 2 steps of work. Distribute the 2 like that. Move the 6 over. If I move that 6 over there, it becomes plus 6. 2 plus 6 is 8. There's the parallel. Y equals 2x plus 8. That's an x, by the way. It's a bad one. Now, to do perpendicular, I'm using the same point. I'm still using y minus 6, but the difference is instead of using 2, you got to use the opposite reciprocal. So I'm putting negative 1/2, and I'm going x plus 1. Doing the same 2 steps. Negative 1/2 times x is negative 1/2 x. Negative 1/2 times 1 is negative 1/2. One more step here. Move the 6. If I move the 6, it becomes plus 6, and here I go. I'm doing the 6 times 2. That's 12. Minus the 1, because it says minus. Minus 1 is 11. 6 times 2 is 12. Minus 1 is 11. Halves. There it is. Just be careful with your fractions. Y'all are, the last couple of weeks, these problems have been pretty good. It's just the fractions that are, messing you up a little bit. One more page. 14, 15, 16. 14, given that f of x is that, find f of a minus 3. Anytime you see f of anything, that just means you're going to plug it in for x, right? So I'm going to say f of a minus 3 equals a minus 3 squared plus 3 times a minus 3 minus 4. All right, so square, multiply, double, squared. That's where most people miss this problem. Second part, distribute the 3. 3a minus 9 minus 4. Now to finish up, just add what you can. A squared, there's nothing to add it to. I've got a negative 6a and a positive 3a. That's negative 3a. And then, like, I've got a 9 minus 9. Those are gone. They're out of here. It just leaves a minus 4. And, guys, there you go. That's it. 15. Find the equation of the circle with center. 2, negative 5. Let's go ahead and do that part first. The center, remember, the opposite always goes in your parentheses. So I'm going x minus 2 squared plus y plus 5 squared equals something. Now, the way you get your something, why does the circle pass through that point? Because it works. So I'm going to take the 4, plug it right there. 4 minus 2 is 2. 2 squared is 4. Plus, I'm going to take the 5, the y, plug it right there. 5 plus 5 is 10. 10 squared is 100. If I add 4 plus 100, I get 104, and that's what goes over there. Now, your answer, guys, is just this. It's not what you plugged in. It's just that right there. Make sure you have the plus sign. Make sure you got the 2 squares. And make sure you get the 104 over there. And you got it made. All right, 16. 16 is slide, divide, slide. I'm going to slide the 2. Everybody always remembers to slide the 2. That's no big deal. And if you do 2 times 56, you get 112. The hardest part of this problem is trying to figure out what factors of 112 give you 9. So I'll try stuff that have a difference of 9. Like try 15 and 6, 16 and 7, 17 and 8, 18 until you find one, and I found it. It is actually 16 and 7. Now, don't be so happy that you got the 16 and 7 that you forget to finish, okay? We just slid. We have not divided yet, so I'm going to now divide by 2. Whatever you slide, you also divide by that. So 16 over 2 is 8, and then I have to slide again, slide, divide, slide. If there's a number in the front, 2, I'm sliding right back there. So there it is. And you can check it, guys. If you'll take 2 seconds to do FOIL down here at the bottom, you should end up right back there. And if you don't, you know you messed it up. Okay, so check it. Hope that helps. Hope you do great tomorrow right before fall break, and I will see you tomorrow.